Good afternoon, everybody. Welcome back to another episode. Made it to Friday. Happy Friday. On my lunch hour again and doing some more studying. I think this is going to be the final OSPF lab that I'm going to do. Maybe I'll do some more in the future, but I'm ready to move on. And so we're going to do day 28 from Jeremy IT Labs today. In the spirit of this channel, viewing this for the first time, I'm just going to try to work through it. This is like the troubleshooting lab. And so this is like the perfect type of lab. You can see on the screen now, something is not working, why, fix the problem. And so this is really going to, I think, test our ability, or I guess our understanding of OSPF. Another little update, I am using my little DJI mic today for the first time. I noticed on some of the previous videos, you could kind of hear my air conditioner basically running in the background, and I'm hoping this provides a little bit better audio and a little bit more clarity. So anyway, let's get started. Okay, the network has been pre-configured, IP addresses OSPF. The connection between R1 and R2 has been newly added. Configure the serial connection between R1 and R2, a clock rate of 128,000 bits per second. Configure OSPF on R1 and R2. So first things first, let's configure a serial connection. The cable has already been connected, so we don't need to reboot the router and insert the module, but it's this module here that's called HWIC2T that you would use to connect a serial cable or to have a serial port available. Anyway, so now let's go ahead and let me move this over a bit so I can kind of see. Configure the serial connection, blah, blah, blah. Okay, so let's do interface. So we need to set the clock. I know that. And it needs to be set on the DCE side of the connection. One of these routers is considered the DCE, and I think the other is considered a DTE. And there is a command to verify that, I think. Do show controllers, I want to say. Is that correct? Do show controllers more? I don't know what that means. Let me back up a sec. Show controllers, question mark. Okay, perfect. Serial, question mark. I don't know. Actually, I just want to do show controllers. What does that do? Nothing. That's an odd, oh wait, no, there we go. Okay, so do the show controllers command tells us about, I guess, just about serial interfaces. But anyway, I think it shows us which one is the DCE versus the DTE. And let me just confirm that on the other side real quick here. So R2, I'm going to say EN, show controllers. I don't understand why it's dropping me into like that less style in the CLI. This is the DTE side. Okay, so we can confirm which side is a DCE, which side is a DTE using that show controllers command. So that's good. And so we know that we need to set the clock on this side. So I'm going to say en conf t, and I want to say clock. No. What is it called? Serial controller clock rate? Clock rate? Maybe I need to go into the actual interface. Interface, serial O/O/O, clock rate, there we go, 128000. Actually, I'm not sure that that's correct because I don't know what, oh, it is bits. All right, so it's possible that it's not always bits, so you need to check anytime you're going to enter a value of some kind. I would check to make sure the type that you're entering is correct. So if this was megabits, obviously that would be different. All right, so bits per second, so 128,000, 128,000. All right, and now I think that is sufficient because the DTE should take the clock rate from the DCE. So let's just try to, well, first of all, let me get out of this. So do show IP interface brief to see what is set up. All right, so the serial ports are set up, but they don't have IP addresses. So I think we need to do that next. So I'm going to say interface serial 000, right? Yeah. And that's going to have IP address 192.168.12.1, and it's a /30. So that's 255.255.255.252. And then I'll say no shut. All right, and exit out of that. And then finally on the other side, blah, 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 I don't need that. All right, so en conf t, and this is interface, serial O/O/O, IP address 192.168.12.2, 255.255.255.252 for a /30. No shut, no shit, no shut. All right, and configure OSPF on router 1 and router 2. All right, so let me just confirm that I can ping router 2 from router 1 real quick to make sure that connection is sound. I'm going to say do ping 192.168.12.2. All right, that works. All right, so let's configure OSPF directly on the interface. So again, interface serial 000. I'm going to say IP OSPF process ID 1 area 0, and this should be all that's necessary. All right, I was watching a video earlier in the week from Jeremy IT Labs when he said that in real life you want to be consistent about whether you enable OSPF on an interface directly in this manner or using the router OSPF configuration network command. So something to keep in mind, which I guess makes sense, but I guess things can get difficult to debug if you've enabled OSPF in different ways within the same area. Okay, so that is that on R1, and now we need to enable it on the serial interface for R2. So I'm already in the interface, so I'm going to say IP OSPF process ID 1 area 0. All right, so OSPF should be enabled. Exit. Let's see. Now you can see that there's already a full adjacency made with the R1 router. So that's good. I think then that we are good. So let me just do show IP OSPF interfaces just to see what interfaces, and actually I can do brief. So we can quickly see that now we have OSPF running on the gigabit interface and the serial interface. And so that's what we wanted for that one. And I would expect to see the same for the next one here. So do show IP OSPF interface brief. And we see it now running on the serial interface. Okay. So let's see. Only R3 has a route to 10.0.2.0/24. Why? Okay, only R3 has a route. So first of all, here's 10.0.2.0. So R3 has a route to this thing. Let's just confirm that. En show IP route. Yes, it does. It's locally connected. So it hasn't learned that route via OSPF, so that's interesting. All right, let me turn this down. The next interesting thing, what is it? All right, so we looked at router 3. Router 4, let's just look at its routing table. So there are neighbor connections being made. So let's see, en do show IP OSPF is let's see, is OSPF running on the interfaces here? So move this out of the way. So for router 4, OSPF is running on the gigabit 01 interface. 192.168.3.4.2, that seems correct. Let me do show IP OSPF, and then I'm going to do it on that specific interface. Gigabit, can I say interface, gigabit Ethernet 01. All right, so this gives us some information that I think we need to use. I'm going to leave that there. I'm going to say show IP OSPF neighbors. So does it have a neighbor relationship? Does R4 have a neighbor relationship with R3? That's the question. R4 has a neighbor relationship with 192.168.3.4.1, and it's in full state. So out of the G01 interface. So that seems correct. So why would R4 not be learning routes known by R3 if R4 has a full neighbor relationship with R3? And no other router has those routes that are known by R3. So something is up with the connection between R3 and R4. What is it? Man. Let's just look at show IP OSPF interface, and then on R3 it's the gigabit 01, gigabit Ethernet 01. All right, so are they in the same area? Let me just pull them up side by side. This is annoying. Man, okay. R4. I want to have them side by side. There's got to be a better way to do that too. All right, so, okay. We can actually put this like that so they're next to each other. So we're looking at the 01 interface for OSPF on R4 and the OSPF interface, gigabit interface 01 on R3. So first of all, they need to be in the same area. I know that. All right, area 0. They need to have the correct subnet. 192.168.3.4.1, 192.168.3.4.2. Now just to double check, I'm pointing as though you can like see where I'm pointing. 192.168.3.4.1 and 2. So those two seem correct. All right. Oh, I see it. Well, I was going to say the process ID, it shouldn't matter, the cost, but look at this. The network type for the R3 gigabit 01 interface is point to point. The network type for the R4 is broadcast. I think this is going to be the issue. Let me check another router and see if like the rest of them are broadcast, and then I'll come back, and I think we'll probably need to make R3 broadcast as well. So let's look at router 2. So let's check its gigabit. So do and see what it is, what network type it is. Do show IP interface, no, IP OSPF interface gigabit O/O. It's broadcast. All right, I think that's another very good data point. Let's try the same. So now we actually, yeah, it's not enabled on G00 because it's not connected to a router. No need to share a route, I don't think. I could be wrong about that. But anyway, let's, on the serial interface that we configured is the default network type broadcast. I'm just curious about that. So I'm going to say do show IP OSPF interface serial O/O/O. Now it is point to point. That's kind of interesting. And I assume on this one, the gigabit is probably going to be broadcast and the serial is probably going to be point to point. All right, so we know the gigabit is broadcast. The serial, I bet, is point to point. So same command, serial O/O/O. That's point to point. All right, so regardless, I think in order for these two need to match. So the connections pointing toward each other, for lack of a better term, the connections, the segments, the interfaces on either side of a segment need to match as far as network type is concerned. I think that's the lesson. They don't need to match across the entire area because from a serial connection, you can have point to point, but you can't have point to point and broadcast on either end of a segment or either end of a connection. So I think that's the problem. And so therefore, for router 3, I think we want to reconfigure this to be a broadcast. Now, how to do that, I have no idea. I'm going to try to go into the interface first. Conf T interface gigabit 01 IP. I'm going to say no IP OSPF. Then what do I have? Cost authentication. Maybe it's a process ID question mark area 0 question mark. No, that's wrong. This is the network type. Oh shoot, network type. All right. No IP OSPF network question mark. Is that it? Point. All right, let me see. I gotta Google it. How to change IP OSPF network type Cisco router. Enter interface configuration mode. Use the IP OSPF network command followed by the desired network type. Okay. So you need to actually type that in. So no ISPF, no IP OSPF network. Then we need to say point to point, apparently. Okay. Went down and then it went back. So now is the network type broadcast? I should have a command in here. Why don't I? Do show IP OSPF interface gigabit 01. And now it is broadcast. All right, so that's a good sign. So now then the question becomes, does R4 and the rest have a route to the 10.0.2.0 subnet? So let's check that. Okay, so it's back to a full neighbor adjacency with the router number 3. Okay, that's a good sign. Show IP route. And now R4 does, in fact, have a route learned via OSPF to the 10.0.2.0 subnet. So that is a success. And that is awesome. All right, so I'm happy about that. Here, I want to check that this one does as well. So do show IP route. And it also, so these have propagated up to the remainder of the routers, it would appear. All right, so let me just ping R3 from here to confirm. I feel like I should have always been able to ping R3. I want to see if maybe I can ping R3's interface into the 254 interface. Let me try that. So ping 10.0.2.254, and that works. Okay, so that's a success. So that's cool. All right, moving on to the next one. Router 2 and router 4 won't become OSPF neighbors with router 5. Why? Fix the problem. All right, so let's just confirm the problem. I'll say do show IP OSPF neighbors. And router 2 has a neighbor relationship with 192.168.12.1, which is router 1, and 192.168.245.2. 245.2 is router 4 along this segment, but it doesn't have a relationship with this router 5 on the, looks like 192.168.245.3. Okay. So we confirmed that the problem exists for router 2. What does router 4 have? Show IP OSPF neighbors, 3.4.1 and 2.4.5.1. So same. So it has 3.4.1, which is R3, and 2.4.5.1, which is R2, but not a relationship with 2.4.5.3. All right, and then let's just check what R5 has in its neighbor table. Show IP OSPF neighbors. And it has no neighbors. All right, so let's just check the basic configuration again, just like we did before. So first of all, we haven't looked at router 5 yet. So is OSPF even running on any of its interfaces? So I'll say show IP OSPF interface, and I actually want to do brief so I can just see the quick list. So OSPF is running on the gigabit 00 interface, and so that's good. And it's 192.168.245.3, so that makes sense. All right, so now we want to, okay, we have it up here already. So I want to do like the side-by-side comparison. So let's check 2 and 5, the same way we did, like basically the same way we debugged previously. And I will just go up to this section here. All right, so we're looking at this compared to, oh my gosh, this. All right, so they are in the same area. That's good. They have, I can already see, the same broadcast network type. They are in the same subnet, 192.168.245.1, 192.168.245.3, both a /29. They have the same process ID, which I don't believe matters. I see it. The interval, the timers. This can cause issues. The default hello and dead timers are 10 and 40. 10 seconds and 40 seconds. 10 for hello and 40 for dead timer. And router 5 has them changed. Router 5's is 5 and 20. That will cause issues. And I think that will prevent neighbor relationships from forming specifically. So I'm going to get rid of this one and just confirm that's the same case. If router 4 also has the default timers, then I think the issue is that router 5 doesn't, and we'll need to change those. So back over here, router 4, and I think I should just be able to scroll up to this section. So the question was, does router 4 have the default hello and dead timers set? And it does, 10 and 40. All right, so the issue is that someone modified the hello and dead timers for router 5, and because they don't match the routers on the same segment, they can't create together a neighbor relationship. So these two have different hello and dead timers than router 5. All right, so how do we change those? Again, I'm going to go into the interface. En conf t interface gigabit ethernet 0/0. I'm going to say no IP OSPF, and then what? Yes, hello interval. If I just say that, I wonder if it'll just revert to, and then the dead interval. If it'll just revert to the default, I think so. So now I'll do exit, and then I should be able to, what is happening? Exit. I don't know why I can't do that. IP OSPF. No. Do show IP OSPF interface gigabit O/O. And now is it gigabit OO? Yes, it is. Okay, and now it's hello and dead timers are reverted to the defaults. So they should all match. And actually, we saw that neighbor relationships were made with 245.1 and 245.2 already. So that's it. .1 and .2, neighbor relationships. And the question was, 2 and 4 won't become OSPF neighbors with R5. Why? Fix the problem. Because R5's hello and dead timers were not set to default or to values that match router 2 and 4. So do show IP OSPF neighbor. And now it's got 2 neighbors. Okay. I think that's number 3. PC1 and PC2 can't ping the external server 8888. All right, so PC1 and PC2 can't ping the external server 8888. So that's somewhere out here on the internet. Ping 8888. Unreachable. So to me, when we're dealing with ASBR routers, what does that mean? Area something border router, meaning the router that takes that sort of represents the path out to the internet. If that's not working, it has to do with default routing. So we either probably didn't run the command for default route originate, or there's no default route on R5 to illustrate, or not to illustrate, to advertise to the rest of the area, like, hey, this is your path out to the internet. So first things first, I want to know if the command to set this router as like the default route originator has been run, default route originate. So how can I know if a command has been run? I can say show running config and see like its configuration. And now there's probably going to be a bunch of stuff here, but I see it already. So it is originating. It's it's representative of the default route based on this command that needs to be entered to do so. So then now I would think that we probably don't have a default route set up. So let's see, show IP route. And yeah, there is no default route set up, I think, which is what this line here means. Gateway of last resort is not set. So because there's no default route, there's no path outside of the area, basically. All right, and so to set up a default route, let me just I think we need to say en conf t IP route, maybe not, maybe I need to go back. IP route router, how do I set up a route? My gosh, let's see. How to create default route Cisco router. IP route, but am I in global config? Yeah, I am, that's weird. Conf t IP route. I don't know why it doesn't tab complete though. That's what I don't get. It's annoying. All right, so IP route 0.0.0.0, 0.0.0.0, and it's a next hop, which is the ISPR's .2 interface. So 203, that's like saying like, hey, any traffic that you don't have a match for in terms of ACL or a route, dump here and it'll go out to the internet. So 203.0.113.2. All right, and now I would have expected router 5 to advertise that default route to all the other routers thanks to dynamic routing, OSPF. So let's check router 1's routing table. En show IP route. And as expected, we now have a default route designated by this star E2, EA2 OSPF external type, out to the internet. So now the question comes, can PC1 ping 8888? Request timed out. Can PC1 ping anything? Can PC1 ping 10.0.1.0 or 10.0.1.254? Ping 10.0.1.254. Yes, it can. Okay. I wonder if we need to configure the default gateway. That is configured. I wonder if I should even expect PC1 to ping 8888, because I don't know if that makes a whole lot of sense to me. Because it's not actually connected out to the internet. And let's just try 203.0.113.2. Let's see if it can ping the ISPR G0 or .2 interface. All right, so ping 203.0.113.2. Request timed out. Interesting. How about another one? Let's say router 2. So 192.168.12.2. Ping 192.168.12.2. So PC1 cannot ping any of those servers. .10.0.1.1. Why? So it can ping its closest router. We know that. But it can't ping, can it ping PC2? Can it ping 10.0.2.1? .10.0.2.1. Request timed out. So why? En show IP route. So router 3 has a path to the internet via 192.168.34.2. Okay. It has a path to 192.168.245. So it can get there. 192.168.12, it can get there. It can get to 10.0.2.0. 10.0.1.0. Yeah, that's interesting. There is no router 1. I think we do need to enable OSPF on G00 of router 1 and then just make that a passive interface. But I think it needs to advertise this route, and it's not doing that. So let's do that. First of all, show IP OSPF interface brief. It's not on the G00. Let's do that. All right, so interface. Yeah, that makes total sense because, and I'm curious actually, is it on 10.0? So sorry, do show IP OSPF. I'm just like rambling, but I think I have it. Show IP OSPF interface gigabit, no, brief. So in this case of router 3, which is kind of analogous to router 1, we do have OSPF running on the 00 side. And that to me means that PC2 should probably be able to ping out to the AS, beyond the ASBR, to the ISPR.2. So let me just verify that. So PC2 to 203.0.113.2. Desktop, or maybe just 8888. Maybe that is supposed to work. .8.8.8. And it works. So that's the issue. Sweet. All right, so I guess you can just ping 8888. I don't really, I think that is what Google's DNS server. I don't really know how that works yet. But anyway, so I think I'm correct in that we need to go into this. So it's en conf t interface gigabit OO. We'll say IP OSPF process ID 1 area 0. And that way, now it should advertise the route to 10.0.1.0. So let me just confirm that. Show IP route. And does it? Yes. Now this router has learned about the 10.0.1.0 subnet via its neighbor. All right, so PC1 should be able to ping 8888. 8.8.8.8, which it can. There we go. And let's just try again the 203.0.113.2. Ping 203.0.113.2. And it can. All right, so ping connectivity is hooked up. And just for the sake of completion, or I don't know what the word is, thoroughness, let's try to ping PC2. Ping 10.0.2.1. And that works. All right, so that's the good feeling that we get when basically things work. So PC1 can ping through all this, all the way over to PC2, and it can ping through all this and out to the internet successfully. So that's what we're going for, and that's pretty awesome. That we're able to basically configure all that, and it's not static. So all of these routers share routes to their connected subnets via the OSPF protocol. So that's very exciting. All right, now examine the LSDB, number 5. What LSAs are present? So examining the LSDB, let's get out of this. Show IP OSPF database. There we go. So we've got route blah blah blah. We've got, let's read. OSPF router with ID 192 blah blah blah, process ID 1, router link states. So I think these are type 1 LSAs. Link states. So link ID, ADV router, age, sequence, checksum link count. Then we have type 2 and I believe type 5. And that's correct, yes, type 5, which is the external. The type 2, I want to say, are broadcast, or maybe they're BDR designated routers and backup designated routers. I got to study up on those. But yeah, and again, just for the sake of completion, unless something in the network changes, the databases should match. So between all the routers that are sharing information via OSPF, all of their databases, I think, should match. I think that's a correct statement. So I'm going to say en show IP OSPF database. And looking at this, of course, the timers aren't going to match, but the LSDBs all match because the LSDB represents what the network looks like to each router. And if there is a difference, then everything gets reset. So as long as the network doesn't change and its topology doesn't change, the LSDBs across all the routers should be identical. Okay, that is it. That was exciting. I think I'm ready to tackle OSPF on the CCNA. Not ready yet to tackle everything because there's a lot. This exam is a beast of an exam. It's a beast of a body of knowledge. And that's one thing I realized coming into this. I did not expect it to be as much as it is. But if it was easy, everyone would get the CCNA. So keep pushing through with patience and persistence, and eventually we will get there and go further. So that's the plan. All right, everyone, have a good weekend. Have a good Friday. Enjoy your lunch hour, and I will see you on the next one. Thank you.